Okay, this will be the review for the final, which will be taking place next Wednesday, and that will be the 13th of May. And so this will review the homework from April 22nd, April 29th, May 6th, and May 13th, and 50% of your final exam will be taken from those questions. 25% of it will be based upon the test material of test 3, and 25% for tests 1 and 2. So since there's going to be 80 questions total, that means that there's going to be 40 over the material that we're going to be covering right now. There's going to be 20 over test 3, and 20 over tests 1 and 2. So review those other materials as well, so that you have everything set and will do extremely well on this final exam. So anyway, so let's go through these. April 22nd. Water is able to dissolve certain ionic compounds because water is made up of strongly polar molecules. The answer is C. Adding solutes such as salt, what has what effect on the freezing point? It is lowered. A, it is lowered, okay? Then continuing on, 3, the equilibrium expression is just the products of the concentrations of the products divided by the concentration of the reactants, right? And so 3 is A, 4 is B, and if a reaction quotient is greater than the equilibrium constant, that means the reaction needs to proceed towards the left to reach equilibrium. Okay. Likewise, the number 6 then is less than the equilibrium constant. The answer is C. The reaction needs to proceed to the right to reach equilibrium. And the electronic device to measure hydrogen ion activity is a pH meter. And the glass electrode is what is best used there. Number 9. The equivalence point, the pH, is greater than 7, okay? So titanium weak acid, the pH at the equivalence point is greater than 7. A weak base with a strong acid, the equivalence point, the pH, is less than 7. So this is a weak acid with a strong base. This is a weak base with a strong acid. Whichever one is strong, the pH is going to be towards that side. That's why it's greater here, lesser here. Strong acid, strong base, it's at 7. Okay, equivalence point, strong acid and strong base, you get a salt and water, just like we did during when you did that one lab. Phenolphthalein is used as an indicator. The answer is C. The color change goes from colorless to pink. The answer is A. 15, the answer is red. Litmus paper turns red with acid. And then 16, litmus paper turns blue in a base. The conjugate acid, okay? So conjugate acid is HCO3 minus. This is the conjugate acid when carbonic acid is dissolved in water. The answer here is B. This is the what is the conjugate acid form? Okay. The conjugate base. This is a repeat of 17, but it's just a different order of these, and surprisingly that would manage to confuse some people. The rank the following oxyacids in order of acidity. This is the least acidic. This is the most acidic. As you add additional oxygen to these, it becomes more acidic. In other words, the hydrogen ion is easier to dissociate. That's why this is the correct order. pH of 10 mils and 10 mils, it's going to be 7. You have equal number of equal molar, right? Here you have 10 moles and 10 mils and 5 mils of the same. And so this right here is more. So this is going to be acidic. 3 mils and then 20 mils. And so this one's going to be basic. Okay? Pretty easy to figure out. The hydronium ion concentration, pH of 7, is 1 times 10 to the minus 7th moles. The student titrates it. The pH is minus 0.23. And this right here is minus 0.10. And then 27. Okay. A titration experiment. Now, what you're unknown is this right here is the unknown. So what you're going to do is you're going to be titrating with a standardized HCl solution. So it has to be this one or this one. Okay. Then at the equivalence point, is used to titrate that, and the moles are equal to the equivalence point, and so the answer is A right here. So a slight difference between these two, but the answer is A. pH 0.048 is 1.3. In other words, all they're doing here is just allowing you to use your log tables and to figure these things out. Deionized water, pH is 7. Hydroxide, if 23% H is that right here, it's going to be 2.73 times 10 to the minus 15th molar. Okay, so this is going to be pretty close to POH of 14. This is almost all acid there. Acid, this one right here is the acetic acid. This is the highest molar concentration, therefore it has the lowest pH. The highest, here you have different ones. They are all highly dissociating ones, so it's going to be the ones with the highest number of moles. That's going to be HBr. Base in the following reaction is H2O. It has to be something on this side of the reaction. This is the acid, right? Very clearly. So this has to be the base. pH of the solution of 7 is POH is 7. Okay, because remember it has to be 14 minus this equals what the POH is. This is a 2, so 14 minus 2, that means this is a 12. And then we have practice here writing the equations. You have your products in the numerator, your reactants in the denominator, and if there's a coefficient, it's raised to that power. Here, pH is 7 only for a deionized solution, only at normal temperature. If you raise the temperature, you get a different hydrogen ion concentration. So for pure water, these concentrations are going to be the same. So that okay, so this is squared, and so your hydrogen ion concentration in both of these cases is going to be 3.05 times 10 to the minus 7th. Now what you do is you take the negative log of that to get the pH. Then what you do for the POH is you take 14 minus your pH to give you this value. Okay? And what you do on this one, you take the negative log of this and then the negative log of this. The negative log of this is just going to give you 7. The negative log of this gives you the minus 0.484, right? So that's why the pH is below 7 for this particular one. Continuing on then, on to the next chapters. For organic chemistry, we have this right here is 60.1 grams per mole. We all know how to calculate. If you know the formula, you know how many carbons there are for 12, how many oxygens, and how many hydrogens, right, to give you that value. Carbon atoms can form so many different ones because they can combine with up to 4 other carbon atoms as well as other kind of atoms. So the answer is A. 2 is isomers. Those are the same molecular formulas, different structures. Incorrect alkane, okay? It's this one right here. The alkane formula is C sub N H 2N plus 2. So this is 1. 2 times 1 is 2, plus 2 is 4. 2 times 4 is 8, plus 2 is 10. 2 times 8 is 16, plus 2 is 18. So these other ones are right. This one right here should be C2H6 for it to be correct. And continuing on, the most stable, single bonds are more stable than double or triple bonds. The most likely found in gasoline is this one right here. Okay, that's C7, very close to the C8 for the octane. All of those are the same group of hydrocarbons, yes. This right here, different alcohols have one OH functional group. Building block of all proteins is alpha amino acids. The next one we have polyunsaturated acids have a higher number of units with double bonds. That's what unsaturated means, is a lot of double bonds. Synthetic polymers, they are derived from fossil fuels. Radioactivity, we've got one instability from struggles between electromagnetic and nuclear forces. That's what causes that there. Proton is the one that's not going to be coming out of the nucleus. A beta particle is called a beta ray. It's an electron from the nucleus. This right here, after joining with subatomic particles, it finds itself in a child's balloon. That's helium. Remember, H, this is the helium. 2 protons, 4 species altogether, though. So this right here is going to be what's found in your child's balloon. The beta particle, this is electrical discharge, lightning and thunder, right? That's an electron. The nucleons now contains the same, okay, because beta particle doesn't have changed the weight by very much. The nucleus by alpha particles is now less, and then continuing on, compared to a is always less. Enriched uranium has more uranium-235. This is the highly radioactive one. So this is what you have more of anytime you have enriched uranium. And number 10, the mass is an intermediate mass number. Continuing on to the next one, we've got gypsum is not like these other 3. Cleavage, that's controlled by the internal crystal structure. That goes into a plane or some other type of one. That's most difficult to scratch is quartz. Of these right here, gypsum and calcite are fairly low in the Mohs index. Does not belong. The schist does not belong. Does not belong is marble. And here are endlessly changing from one type to another. That's the rock cycle concept that they have. Okay, tectonic plates, this right here is continent to continent. Okay, least likely, to be as frequent, right? A deep ocean trench is most likely associated with what type of plate boundary? A convergent one. Evidence that the Earth has a liquid outer core and solid inner core is from earthquakes. And then what you have below that is you have 10. How far would a plate be expected to move in a century? That's 100 years. It's 3 meters. 3 meters. Convincing evidence is paleomagnetics. In other words, the magnetic structure of very old rocks. The ocean-continent convergence is the Washington Ocean coastline. Appalachian Mountains, that is an example of folding. Okay, folding. Sierra Nevadas are faulting. And then the fault block, those are your Teton Mountains. And then the volcanic activity, the 4th type, is the Mauna Loa in Hawaii. Okay, each time, the Richter scale, that's a log scale. So that means each one is 10 times more. Most important agent in erosion are streams. The one that does not belong with the others is the U-shaped valley. Okay. Glaciation might leave a deposit of called a moraine. And then we have the slow flowing stream with meanders and a wide floodplain is developed old age. And is it possible of erosion without weathering? No, it is not. And there will be one more video, and we'll continue in the last section on that